Hello everyone. So in this session we are just going to discuss about the memory system and hierarchy. How this memory system is organized, what are the different levels of memory, why we offer memory at different levels, what is the hierarchy to be followed, and different classification of the memory, and salient characteristics of the memory. So like this we will be discussing about various concepts related to memory. To start with, we will just see how the memory is going to be categorized. Maybe you can just have a look on this diagram. Okay, let me just so in this memory system, we have the CPU, and inside the CPU we also have some basic hardware that can store the data items. That is what we call as registers. So this is going to be the smaller level of memory, which is very closer to the CPU. Okay, after this, then when we come to the next level, we have the concept of cache memory, and this cache memory can be made available in three levels: level 1, level 2, level 3 cache. And some cases this cache memory can also be framed on the chip of the CPU. Then it is going to be called as on chip cache, otherwise it is going to be called as off chip cache. So if you just consider this, the cache memory, it is going to be called as a frequently accessed memory. So all the informations which are going to be frequently accessed are going to be kept in this memory, and this memory itself is available in three levels. So the CPU will first look for the information first in the level 1 cache. If it is found, it is going to be called as a hit. If it is not found, it is referred as a miss. So it will go to the next level, and again it will continue the process till it identifies that particular item. Then the next level of memory is called as main memory. After this cache memory, we have the main memory. So these two memories are going to be directly accessed by the CPU, and these are just available only as a temporary storage. That means if the power is going to be switched off, the content of these memories are going to be lost. So only for temporary purpose we will be storing, and whatever that is available in this cache memory or in this memory is going to be lost when the power is off. So it is referred as a temporary storage memory, and these are the two memories in which the CPU can have direct access. Coming to this main memory, this main memory can be realized with the concept of physical memory, which is actually available in the form of the chip. And also, we will introduce a concept of virtual memory, and this will be discussed in detail in the later classes. But now, this main memory can be identified either as a physical memory or as a virtual memory. So, all this comes under temporary storage. Then, the next level of the memory is going to be called as secondary storage, and here we have all the memories available in this levels are going to support permanent storage. Whereas in the previous two levels, it's going to be temporary storage, and these temporary storage memories are going to be directly accessed by the CPU. Whereas here, it is going to be permanent storage, and as far as the operating system is concerned, it will help the CPU, and it will assist the operating system will assist the CPU to access the information available in the secondary storage. So some of the secondary storage devices are identified here as ROM, okay, read-only memory, and that is very much well known to store this operating system, basic input output system, power on self test routines. Like that, the important driver routines and other operating system related softwares will be made available in ROM. And we can also have some removable drives in which we will be having some storage unit, and we can access that removable that storage devices using this removable drives. And there can also be a network internet storage. Okay, network, it is available in the form of ICs, and we can also have hard drive. So these are the various type of storage structures, that can be provided at the secondary storage level. Okay, then the last level of the memory, the next level is going to be the input output devices, which are going to have some buffer mechanisms, and also can have their own storage components, where these keyboard, the mouse, the removable media, the scanner, the camera, the video devices, and the remote source or other source, these sources can receive the data from the user, and they can have it in some temporary buffer sort of structures, and then it will transfer the content to the secondary storage, and from the secondary storage it will be moved to the main memory by the loader available in the operating system. And then if they are going to be frequently referred, those items alone can be brought to the cache to the next level, and then it will reach the CPU. This is going to be the hierarchy of access across the different levels. The same levels, it can be identified in this diagram here in a different way. So we have the registers and then cache and L1 cache, L2 cache, which is made up of a static RAM, and then we have the concept of main memory, which will be comprised of dynamic random access memory storage devices, and then we have some local secondary storage, which are otherwise referred as a local disk, and we can also go for the remote storage like cloud systems or tapes or distributed file systems and web servers. So these are going to be the different levels, and these levels are numbered as L0, L1, L2, L3, L4, and L5. And if we just observe these levels, what are the features available in these levels? If we just go away from the CPU, as we keep increasing the levels, the size of the memory is going to be increased. So the first point to be observed is the size of the memory is going to be bigger as we approach away from the CPU. Okay. Then slow. Okay, as we go away from the CPU, the speed of access will be very slow. That means if the CPU is going to access something in the registers, it will be high speed. Whereas if it is going to refer from the secondary storage, or if it is going to be referred at the highest levels, obviously it will take too much of time. So it is going to be the speed is going to be very slow when I go away from the CPU. Of course, the size will be higher. Okay. And apart from this, we also have one more parameters to be compared, that is called cost. Okay, as we just go nearer to the CPU, the cost will be more. Okay, it is going to be expensive, highly expensive, because it is going to involve so many hardware components. Okay, so as far as the cost is concerned, if we go nearer, it is going to be high. And as far as the speed is concerned, it will take too much. Speed is also going to be high as I go nearer. And as far as size is concerned, it will become high only if I go away from the CPU. So the three important metrics or the parameters that can provide the capability of the memory is the speed, the size, okay, and then the cost. So the speed, size, and cost, they are interrelated in this way. So as far as this arrow is concerned, it is related to the cost, the speed and the size. As we go away, the size is also more, and speed is also going to be slow. And whereas if I just go nearer, the size will be small and it will be costlier. Okay. So this explains you how the different levels of memory is going to vary by itself in terms of cost, size, and speed. This block diagram explains how the connection is going to be established across the memory. As we all know, here we have the CPU. Of course, the CPU has to be provided with the information. So we have different types of memory as we discussed. So the one which is going to be inside the CPU is going to be registers, and we have the cache memory here. Always the CPU will interact with the cache memory. If the item is not found, then it will look into the main memory. And if it is there, it can use it directly, and at the same time for future references it will keep it in the cache memory. And if it is not in the main memory, then it has to be brought into the main memory. For that purpose, it has to refer to the secondary memory. The secondary memory are also called as auxiliary memory, and the main memory is going to be called as a prime memory. So in this auxiliary memory, we can have different type of secondary storage devices like magnetic tapes, magnetic disk, like that. We can have any type of IO devices. So this storage devices all will come under the auxiliary memory, and the information available in this secondary storage are going to be transferred to the main memory with the help of the IO processor. So we have a kind of a processor dedicated for IO activity, and in order to make the CPU effective, we just assign the process of transferring the data from the secondary memory to the main memory by the IO processor. And once it got transferred to the main memory, it will be directly supplied to the CPU, or if it is going to be frequently referred, it will also be stored in the cache memory. So this is going to be the access mechanism which is going to be followed by the CPU. Every time it will look into the cache memory for data. If it is available, it will use it. Otherwise, it will refer to the main memory. If it is there in the main memory, it will use it. If it is not there in the memory, it has to be brought from the secondary memory to the main memory with the help of the IO processor. This diagram explains the classification of the memory. So as we all know, based on the levels, we have the registers, okay, the primary memory, the cache memory, and the secondary memory, okay. And the registers, of course, it is going to be the hardware unit, which is of limited in number and limited in size, and it is going to be the smallest memory available, and it is going to be the fastest memory, and it is the costliest one. Okay, then coming to the primary memory, this primary memory can be classified into two types. One is called as RAM, and another one is called as ROM. As the name implies, RAM, it is referring to read and write, okay, random access memory. Here it is going to be called as, the ROM is called as read-only memory, and this read-only memory is also going to be available in different types. One is called as mask ROM, and then this is called as PROM, which is called as programmable read-only memory, and this is erasable programmable read-only memory. And how we are going to erase? If we are going to use electrical signals for erasing, then it is called as electrically erasable programmable read-only memory. And we also have one read-only memory which is called as a flash ROM. So these are the different types of ROM available under the category read-only. Whereas if we just take read and write memory, or otherwise the random access memory, so here we have again further classified this read-write memory into two categories. As the name implies here, this memory can be used to both read the information and also the write information. Whereas here in this memory we can only read, we cannot write. So if we cannot write, how can we read it? It has to be programmed. So the manufacturer, once they fabricate this IC, they will program it, and after programming you have to use only for read purpose. Okay, now coming to this read and write memory, this read and write memory is called as RAM and ROM. Okay, sorry, read and write memory is going to be classified in two categories based on the type of access it is supporting. One is called as random access memory. Another one is called a sequential access memory. So what do you mean by random access? At random, you can go to any location and then access the content. Whereas sequential access, right from the beginning, from the first track, you have to access the memory. Maybe you can just relate with a real-time example. If you're just going to hear the songs using CDs, so you can play any song at your wish, at your well and wish. So if you're able to play any song, whatever you desire at any time, then it is going to be called as random access. Suppose if you are going to listen to the songs from the cassettes, or audio tapes. So in that case, if you want to play the fifth song, no other go, you have to traverse all the four songs, then only you can reach the fifth song. Either you have to traverse one by one, or you have to fast forward. So this will support only sequential access. Always you have to start from the beginning. Whether you like it or not like it, you have to trace it, and then you reach the location. Whereas in random access, at random you can go to any track, any sector, and play that information available in that. Okay, so this random access memory can still be further classified into static random access and dynamic random access, and this classification is based on the nature of the component which is used to frame these devices. Okay, if you are going to use capacitors, then the capacitors will be charged and discharged. They cannot store the data item for longer period of time. So every time it has to be recharged. So dynamically it's going to change, so we have to refresh it every time. So that is going to be coming under the category dynamic random access. Whereas if some other components like flip-flops are going to be used, the content stored in this RAM is going to be static or fixed, so need not refresh it. So that will come under the category SRAM. Okay. Now coming to the secondary memory, again the secondary memory can be classified into two categories based on the access which we are going to do, whether it is going to permit serial access or it is going to be semi-random. So if you just identify what are the devices which are coming under the category serial access, you can look into this: the magnetic tape, the CCD charge coupled drive, and then the ferrite core. So all these type of storage devices will come under the category serial access under the secondary memory. And then semi-random access, so all the direct access disk, the compact disk, okay, the high definition disk, the digital versatile disk, the floppy disk, all these will come under the category semi-random. Why it is called as semi-random? You cannot directly do access the content directly, you cannot do a random access. At the same time, it is not sequential also, so it is going to fit into the category semi-random. So this diagram explains you the classification of the memory into different categories, where we have the main classification as primary memory, cache memory, and secondary memory. So the primary memory is going to be classified as whether it is going to permit read and write operation or read only. Okay, and those which permits both read and write can be further classified as random access and sequential access. Okay, which is again further classified into static random access and dynamic random access. Whereas if you just take read only memory, it will be classified into different types based on the type of access it is going to permit and how it is going to be erased. Okay, then coming to the secondary memory, it can be serial access or semi-random access. So the serial access will have the magnetic tape, CCD, and ferrite core under this category, whereas all the remaining will come under the semi-random access. So we have just discussed different levels of memory, the hierarchy of memory, how these different levels of memory vary in terms of speed, cost, and uh, uh, size, and we have also discussed the various classification of the memory.